Venus is often described as a world frozen in time, a scorching planet that reaches temperatures almost to 900 degrees Fahrenheit, with a toxic atmosphere and a surface that appears like it's been remained unchanged for millions of years. But that picture's just about to change. Now, scientists over recent years and what just came out is that there's growing number of evidence that Venus is still geologically active, with signs of volcanic activity, but also cracking through the surface. If Venus is still alive beneath its clouds and completely changing how we understand the planet's past, and probably the future of Earth entirely. So, what is really happening beneath the surface, and how is it similar but also different than Earth? So, welcome to the universe. My name is Chris. Let's get started. So, Venus is a very different world than what it was back in its past. I mean, today, Venus's surface is nearly almost 900 degrees Fahrenheit, even hot enough to melt lead. And its atmospheric pressure is 92 times that on Earth. That means it's similar than being 3,000 feet below the ocean. That's crazy. If you had a 16-inch pepperoni pizza on the windowsill of your house on Venus, it would instantly cook the pizza in just 2.5 seconds. But you want to not eat that pizza because that's covered in sulfuric acid and it's already burnt right through it. And also you won't even survive the sulfuric acid because it's so corrosive. But again, billions of years ago, it was a very different world. Now, early in its history, Venus may have been a cooler and could have supported liquid water on its surface. And it had rivers, lakes, oceans, and also has its own water cycle similar to what Earth has today. So because Venus is similar to Earth in size and composition, scientists do believe that it may have initially experienced some of the same geological processes early on as similar to Earth and Mars, because they were born at the same time, they're born in the same stuff, but two planets out of the three had a very different history, but two completely different opposites. Earth, on the other hand, managed to thrive. And it's become the only planet that we know of to support life and support humans. So, what did happen? Well, Venus did have tectonic activity early on because of the churning and the composition changing. So it was churning in its interior, creating cracks and that filled with magma, and also hot spots from the mantle kept pushing the crust up and creating volcanoes, just like Earth. Today, Earth has tectonic activity, tectonic plates. It's divided in 12 tectonic plates. Venus, on the other hand, may have had tectonic plates early on in its history that became hot spots, cracks, and fissures, and plate movements. But Venus went through a very deadly fate. Venus is actually closer to the sun than Earth, meaning that it's more possible for a runaway greenhouse effect because the water couldn't stay for that long because it's closer to, and it's a different luminosity. So it's a higher luminosity because it's closer to the sun. So over time, increasing solar activity and changes in the planet's climate may have caused Venus to lose so much of its water, and also that water created water vapor because it's in a different stage, it's gas. So, but if you didn't know, you know that carbon dioxide, that one stuff that we're putting into the atmosphere today, but you have to realize that water vapor itself is even deadlier and more potent than CO2 because it's in the higher parts per million. So pretty much all that water vapor, because of all the evaporation from all that water, all of that stuff built up into the atmosphere, and so did the carbon dioxide, the methane, the sulfurs, and all that stuff that came out of the magma, and all the stuff that came out of these volcanoes. And all that magma, from its tectonic activity and all the volcanism, all of that spread across its entire surface, leaving behind basaltic rock. Basaltic rock is volcanic rock. Similar to what Mars had volcanic activity, but also carbon dioxide and iron. And all that water has evaporated out into space. But Mars was stripped out of its atmosphere and its magnetosphere. Venus, on the other hand, gained a new atmosphere. Its climate was altered. Venus's atmosphere thickened, leading to a runaway greenhouse effect, pushing surface temperatures and its air temperatures to go even hotter. So its surface temperatures became from a very cool 70 degrees to eventually pushing temperatures up into the triple digits. And then kept going and going and going as the sun's luminosity also increased. And eventually what we see today is that Venus's surface temperatures are about 870 degrees Fahrenheit. An atmosphere dominated by carbon dioxide, 96%. Evidence of Venus also suggests that enormous volcanic events and widespread resurfacing played the important role in that evolution. So, what do we know about today? Is it still volcanically active? Let's talk about it. Venus is not necessarily a volcanically dead planet. Evidence NASA's Magellan spacecraft and other observations suggest that volcanic activity is still occurring on Venus today. Scientists have identified changes around volcanoes such as matmons and siphons, consistent with recent eruptions. While other regions show signs of heat and geological activity, but also studying the actual atmosphere itself, showing signs of that the atmosphere is thickening and its density is increasing. So suggesting that volcanic activity and tectonic activity is still present on Venus today. Suggesting that there's new cracks on the surface, there's new eruptions, there's new stuff that's blanketing its entire surface, but also adding stuff into atmosphere, and also suggested that whatever presence of water vapor is still in those clouds, whatever amount of CO2 is also still present. So we just see there's evidence from other spacecrafts that we sent missions to Venus. Hey, we already sent the Venera probes, and they suffered the fate being on Venus' surface, where they only stayed for at least 127 minutes before succumbing to Venus' toxic environment. So we just know all the evidence about that. But also, new other missions to Venus in the past, we already sent basically these simulated colored photos of Venus, showing its entire surface without all the clouds, showing that there's cracks, there's lava fields, there's volcanoes, etc. It's a beautiful image though. So but suggesting that these areas on Venus is still volcanically and tectonically active, because Venus does have a very similar interior to Earth, because they're the exact same size and they're still doing the same tectonic activity, but Venus is a little bit different and all that stuff. Venus does have volcanic hotspots, and that's what became matmons and siphons. Just like, let's say if you go to Mars, for example, Olympus Mons was a volcanic hotspot, but that just kept piling up until it gets bigger. Now Mars is 1/2 the size of Earth. That means its weaker gravity suggests that the volcano can grow even taller. Venus, being similar in size to Earth, suggests that, again, there is still a height limit, but Venus's volcanoes can still grow a little bit taller because Venus does have slightly weaker gravity than Earth's. But it suggests that, hey, that these volcanoes are still growing because of constant eruptions. So it suggests that these volcanoes are probably going a little bit slower than Earth's geological time period in its geological activity right now. But it suggests that Venus is still very active tectonically and volcanically. The future of tectonic activity on Earth and Venus is likely to be very different. Earth has tectonic activity. We see large plates continue to move, collide, and separate, particularly because of the heat escaping from the planet's interior. This process is expected to continue for several billions of years. Although the rate of the tectonic will eventually gradually change as Earth's interior continuously cools, eventually the planet will lose more of its internal heat and plate tectonics will eventually stop. Mars went through that issue, but that was billions of years ago. Now Mars did lose its internal heat billions of years ago. Venus and Earth are still active underneath, but Earth would eventually slow down and cool down from its interior and up over billions of years. And it's still cooling down because it's cooling down from the remnants of its birth. But over billions of years, it will completely slow down and cut off all the plate tectonics completely. Meanwhile, Venus does not appear to have Earth-like plate tectonics today, but a large-scale resurfacing. However, Venus is still losing heat from its interior, so its tectonic and volcanic activity will eventually slow down, but also continuously evolve over time. If the planet's interior continues to cool and geologically activity could eventually decline, but scientists are still uncertain how long Venus will eventually remain volcanically active and tectonically active. Comparing these two planets gives scientists an important look at how similar rocky worlds can follow very different geological paths. And also it's uncertain for Mars too, unless we rebuild the Martian interior. How long would that last until after we rebuild it? I mean, will we be learning the fates over billions of years as it's slowly cooling down again? Maybe. But again, we don't know. But just to recap today's video, we know that Venus is still tectonically and geologically active, but also volcanically active. We learn about Venus's past from a rich water world to a hellish hellhole full of sulfuric acid and a thick atmosphere and temperature scorching to hot enough to melt lead. We learn about Earth's tectonic activities. We learn about Earth's history as well. We learn about Mars's history. We learn all about this stuff comparison how Venus is still active and how its future will shape its evolution. So thank you guys so much for watching. I'll see you guys in the next video. Also hit the like and subscribe button if you guys are new for new space videos. And as always, keep exploring.